All right, recording's back, rolling. All right, so you guys have been gathering data for the angle that it breaks friction, no, sorry, the angle it slides down at constant velocity. That's what you're looking at. I'm just gonna make up some stuff to help you guys out here. Suppose this was like this many degrees, this many degrees, this many degrees, this many degrees, this many degrees. I'm just kind of making something up, right? But maybe it's not too far off from what you got. Right? Now I'm telling you here this last column to take the tangent of each of those angles, right? I wonder what that's about. Why would we take tangent? Well, I don't know. Let's see what happens. What's tangent of each of these? This is like this number. These are like decimals, right? It's like this is like this number shows up again like right here. Right, it's the tangent 18 degrees is like 0.32, 0.32. What's the average of these things? Down, 5. Right. It's like 0.31. Okay, something like that. Okay. Then I had you guys make a graph. What is tangent of the angle as a function of the weight? Right. Ooh, tan theta versus. So we put tan theta on the vertical axis. Right. Again, I haven't quite told you guys why tan theta yet, or maybe you figured it out. Right. And I'm going to put weight in newtons on the horizontal axis. I wonder what this graph is going to look like. Well, it's the same weights as before, so I'm going to get scale same as before, 0, 2, 4, 6, 8, 10. Right, and tan of the angle. Looks like a pretty constant value all the way down. Did you guys find that regardless of which weight you used, it was pretty close to the same angle that it was sliding down every time? Should be pretty close, right? Right. So tangent of that, let's go 0, 0.1, 0.2, 0.3. Okay, I think I'll be able to figure out from there. All right, what's it going to look like? All right, so looking at 0.1, it's like 0.9, bam, right there. All right, 1 Newton, it's like 0.31, it's like bam, right there. 2 Newtons, it's like bam, right there. 5 Newtons, bam, right there. And 10 Newtons, 32, it's like bam, right there. Okay. Ooh, great. So the fact that the angles were about the same across, or hopefully you got something pretty close to that. The tangent of the angles were also about the same all the way across. Okay. So we have like a, do you guys think no relationship between the weight and the tangent of the angle? Right? Yeah, that's no relationship, right? So if you craft an equation, it's just like y equals a constant. And I started off for you, I said tan theta, in this case, is just a constant. So I'll just take my average value, which is like 0.31 in this case, 0.31, right? So the last question, that last box here says, how does that relate to coefficient of friction? Okay. And here's where, just to save some time, I'm going to go ahead and take you guys through the full solution. Okay. Okay. So we got this set up. The block is in equilibrium, so there definitely is a friction force. Right. This is not your car and incline lab. There's definitely a friction force here. Right. Slide down, constant velocity. Right. Acceleration 0. Right. I took you guys this far. Then I said the next step would be the friction force is coefficient of friction times normal force. Oh, bam! That's how we're getting the coefficient of kinetic friction. Okay, so now it shows up. That's what we're trying to figure out. Right? And the normal force, isn't that just equivalent to mg cosine theta? So I can substitute that right there in brackets. Hey, at this point, what cancels out on both sides? The weight, right? So not only the lab mass, but also the gravity field for that matter. So you could take this whole system to Mars. I bet it would also slide down at constant velocity at the same angle. Ooh, right? What is sine divided by cosine? Boom, tangent. So as long as it's sliding down at constant velocity, just under its own weight, and of course, friction force, right? Now you guys have a way to find the coefficient of friction with nothing but a protractor and a calculator. Right? I've seen AP ask this type of question before. Right? Do you guys think you could come up with that proof right there for AP, something like that? Maybe. All right. Last thing. Go ahead very quickly. I'm gonna do pause on this recording. You guys do a 5-part write up real fast, and I'll take you guys through the solution.